welcome back. This is Math 980, section 3.2, graphing linear equations. Okay. So in 3.1 we talked a little bit about filling in values, missing values in order to solve for some solutions for an equation. And we're going to do that again here. We're looking for three values. Those values are going to be, when x is 0, figure out the y value that makes a solution. When y is 0, figure out the x value that makes a solution. And then really we just want to kind of figure out some other place where this will work out. So we're going to go with, not 3, that won't work. Let's say 6, right? But we're going to find these three values, and we'll see that these two are extremely easy. They're simple. This one will require a little bit more work. In fact, it required a little bit more thought to even come up with this that will make this as easy as possible. And it's still a little bit difficult. But let's find these values. If x is 0, then I can plug in 3 times 0 plus 5y equals 15, right? But again, if x is 0, this whole term is gone. It doesn't even need to be there. In fact, goodbye. It's gone. I end up with something extremely simple, 5y equals 15, and it's one really quick step to divide by 5 to see that y is equal to 3. And similarly, if y is 0, then I have 3 times x plus 5 times 0 equals 15. But again, 5 times 0 is 0, and 0 plus something else, it may as well not even be there. So I'm going to get rid of it. It doesn't need to be there. And one quick step, divide by 3, and we can see that x equals 5. Those two were extremely simple, very easy, because I had a 0 that knocks out an entire term. Otherwise, say for this one, if if y equals 6, then I'm plugging in 6 for y and solving for x, so that gives me 3x plus 5 times 6 equals 15. The 5 times 6 is 30, so I have to do a little bit of work here, so 3x plus 30 equals 15, minus 30, minus 30, that gives me 3x equals negative 15. And I had to do all of this work to get to the place where I started on the first two, right? Divide each side by 3, and I have x equals negative 5. And it's not terrible, it's not hard, but you can see that these zeros are much easier to work with. And that's the idea of the very first part of this section, is to be able to graph something by simply finding its intercepts. Right? And that'll actually be the point of section 3.3. Right? So we'll get to that a little bit more in depth there. But I can see, if I look at what's happening here on a graph, I'm going to get rid of this work, so if you want it, pause it, because here it goes. If I plot these values, let me throw some tick marks on here. I have a point at 0, 3. So x is 0, y is 3, that's right here. X is 5, y is 0, that's over here, say at 5. And this other point, negative 5, 6, would be I didn't draw my graph very well here. 5, 6 would be there. Okay. So I have 3 solutions graphed here. There's one, there's the other, and there's 3, right? But you'll notice that these fall in a line, right? I can draw a straight line. I can sort of draw a straight line. That's sort of what I missed, but, you know, forgive me. But this line that I can draw through all of these, any point on this line is also a solution, right? And you can see that I could keep plugging in all sorts of numbers. I could plug in, hey, what happens when x is 2? And I'd get something between 2 and 3 as my solution. What if x is 3? I'll get something somewhere around 2. My line is terrible, so I'm sorry. But that's the idea, is that I can find kind of an idea of where all these solutions are. In fact, I can find all of the solutions because they are that line. All right, let's take a look at another example here. Let's say I have the equation 2x plus y equals 4. And again, those zeros are very nice. It's going to be the whole point of the next section to use those zeros as much as you can. So 0 for x, 0 for y, and then figure something out. You know, plug in maybe a 2 for x and see what happens. Maybe not here, because I'm going to see in a minute that it's going to be already one of these points. It's going to be 0. So let's say 1 for x, and see what happens for y. But these first two should be really easy, right? If x is 0, I can just imagine the x term goes away because x is 0 times 2 is still 0 plus y is just y. So I've already got it. Y is 4. I didn't have to do anything. I just had to imagine this being disappear, and y is 4. If y is 0, I can make the y disappear, and I get 2x equals 4. Because the y is gone, and if I divide each side by 2, x is 2. And then what happens if x is 1? I might have to work for this one a little bit, probably not a lot. But if x is 1, I get 2 times 1 plus y equals 4. That is to say 2 plus y equals 4, minus 2 gives me y equals 2. And there it is, I have 3 points. Right? We can graph this. It should make a line. And in fact, you only need 2 points to make a line, right? So I could do this just as well with these first 2 points. But it's nice to get that third one, because if you get a third one in the line, you know you're on the right track. If you get a third one that doesn't make a straight line, then you know maybe you've got to go back and relook at your numbers. But if I graph these guys, right, so throw some tick marks here, 1, 2, 3, 4. 1, 2, 3, 4. I think that's really all I need. I have the point 0, 4, which is here. I have the point 2, 0, which is here. And this last point should be somewhere in that line, 1, 2. It is. It's right there. And I create a straight line. Please forgive me. I can't draw a straight line with these markers to save my life, but that line should go through all 3 of those. I throw an arrow on both ends because it extends forever, because you'll get solutions forever to the left and forever to the right. You might be asked to find some solutions and not be given this chart, and eventually you will, and in fact in this section you will. But let's look at perhaps this. Y equals 3/4 x plus 2, and we're looking for x and y values, and you're not going to be suggested you need to start. Right? Find 3, figure them out by yourself. Right? But I want to avoid fractions if I can, because graphing is hard enough with whole numbers, if you can see my terrible lines. Figuring out where fractions are is even worse, right? But if x is 0, this whole fraction disappears, and that's a nice little place to start. So if x is 0, this becomes y equals, this whole middle term becomes 0, so it's just 2, right? Other numbers that will work are numbers that will eliminate this fraction, like if x were 4, right? So if I let x equal 4, x equals 4 gives me y equals 3 over 4 multiplied by 4 plus 2. The 4 cancels with the 4, leaving me with 3 plus 2, so I get 5. Likewise, I could have said, what happens if x is negative 4? Because the negative 4 will also cancel. The 4 will cancel with 4. And so if I do that one, I get y equals 3/4 multiplied by negative 4 plus 2. The 4 cancels. That leaves me with negative 3 plus 2. So that is negative 4. I have 3 points. I can plot this. So let's take a look at what it looks like plotted. That should do for the tick marks. I have a point at 0, 2, which is here. I have a point at 4, 5, so all the way to 4 and then all the way up to 5. Looks like there. And then negative 4, negative 1. So negative 4 in the x and then negative 1 in the y. And to the best of my awesome abilities, I have a straight line here, right? I missed again. That's okay. But that's my line. And I should have solutions everywhere on it. There are a couple of straight lines that are a little bit odd to come across. Let's say we want to find the missing values to find 3 solutions to the equation. Let's go with y equals 4. And in this case, I'm going to find what happens when x is 0, what happens when x is 1, and what happens when x is negative 1. Right? But as you can see, there's no x in this equation. If x is 0, y is 4 because y is 4, always. Doesn't depend on x. There's no dependence on x. So if x is 0, y is still 4. Well, if x is 1, y is still 4. Doesn't matter, there's no x in here, so it doesn't change anything. Y is 4. Same thing if x is negative 1. If an x is negative 1, it doesn't affect my equation. Y is still 4. Let x be 1,000. Guess what y is going to be? It's going to be 4. Because it's 4 always. Doesn't matter what x is. X doesn't change this. And I can think about the way that this gets graphed. I have a point 0, 4, and that's here. I have a point 1, 4, that's here. I have a point negative 1, 4, that's here, right? You can see what I'm creating here. If I have 1,000, right, it's just that way, 1,000. I'm creating a horizontal line here. Because it doesn't matter what x is. If x is negative 3, what's y? It's 4, right? So I create this horizontal line, it goes forever. And so if I have simply an equation that does not depend on x, it is a horizontal line. Likewise, what if we say x equals 4? And I want to find some values. Let's say when y is 0, when y is negative 1, when y is positive 2, and I don't know, let's say when y is 10,000, right? It doesn't matter here. Because if y is 0, this equation doesn't depend on y, it has no y, and so x is 4. If y is negative 1, who cares? X is 4. If y is 2, I don't care, it's 4. If y is 10,000, guess what? X is 4, right? And so I can think about what happens when I graph this one as well. There's 4 for my x. 1, 2, 4 for my y, negative 4 for my y. I have the point 4, 0, that would be right here. I have a point 4, negative 1, that's right here. The point 4, 2, that's here, and you can see what I'm creating here is a vertical line, right? If my y value is 10,000, right, still 4, that's way up there, but it's still in this line right there. And so if my equation does not depend on y, I get a vertical line out of that. Those are our two little oddballs. If you don't have the dependence on both of those variables, you get something that looks like that. All right, let's look at the idea of these two lines here. So let's look at let's look at this. Something simple like y equals 1/3 x and y equals 1/3 x minus 2. So I'm going to complete charts for both of these. Let's say we have x and y for this guy. All right. Because I'm looking for the values of x that will eliminate this 3, 0 is a good one. 3 is a good one, and I'll go with negative 3. Right? And in fact, it's the same over here. Those 3 will eliminate this fraction, so I'm going to use the same ones. So I'll go 0, 3, negative 3. And in the end, we're just going to compare the graphs of these two equations. But if x is 0, 1/3 times 0 is still 0. That's easy. If x is 3, then I have 1/3 times 3, and that is 1. And if x is negative 3, right, that is 1/3 times negative 3. The 3's cancel, but I still have a negative, so that's negative 1. So I have these 3. I'll graph that in a minute. In fact, let's graph it now. Doesn't matter. Graph it in between these two. Okay. So I have the point 0, 0. That goes right through the center. I have the point 3, 1, so 1, 2, 3, 1 is there. And negative 3, negative 1, so negative 1, 2, 3, negative 1. So I have those. That is my line. Let's graph this other one, or let's figure out this other one. If x is 0, this whole term is 0, so I have 0 minus 2, that's negative 2. If x is 3, then I have 1/3 times 3 minus 2, but 1/3 of 3 is 1, minus 2 is negative 1. Okay. And if it's negative 3, this gives me 1/3 times negative 3 minus 2. The 3's cancel, leaving me with just negative 1, and minus 2 gives me negative 3. So I have these points. I have 0, negative 2, so 0, negative 2 is here. 3, 1, 2, 3, and negative 1. And negative 3, negative 3. And you'll notice, despite my terrible abilities to draw, that these two lines are parallel, right? And so we can notice here that they had the same number in front of the x, and they ended up being parallel, and therefore we define a line based on the way that this is written. So I'm going to erase this real quick here. I'm going to leave that one up there. This is the general form of the way that this equation is written. This is written in slope-intercept form. For now, we're just going to note here that the m is why these two were parallel. If they have the same m, they're going to have that same slope, the steepness of that line. And so two lines are parallel if written in the y equals mx plus b form, they have the same m. And that means that we can then define m as the slope of a line. The other thing that we can note from this, and I've erased it, so that's unfortunate that I only have this one board, but the first equation was y equals 1/3 x. Right? And you can think of this in the y equals mx plus b as 1/3 x plus 0, but on the y-axis, this equation, I hope you looked at your notes, if not, rewind this 30 seconds or a minute or whatever, but this line goes through y equals 0, where this line goes through y equals negative 2 on the y-intercept, on the y-axis. And so we can also then say that these lines, they also have a y-intercept at the point 0. That's what makes it the y-intercept, is my x is 0. But it goes through that point 0b, where b is that number hanging out to the side here. So in this case it was 0, in this case it was negative 2. And that's going to walk us into our next, one of the next sections here. 3.3 talks about graphing using intercepts, and then 3.4 talks a little bit more about slope. So we'll get into that a little bit more. But you can graph things rather quickly using this form. And again, we'll see that again, and we'll revisit it in more depth. So thank you, and I'll see you for 3.3.